All right, when fractions get involved, it's similar to multiplication. If I have the square root of a fraction, I can split that into the square root of the top piece, the numerator, over the square root of the bottom piece, if that helps me with simplifying, or I can go the other way. If I have a square root on top and a square root on the bottom, I can put one big square root over the whole fraction, if that helps me simplify. So on the one here on the left, what we would do is put the square root of 100 on top, square root of 9 on the bottom, and then now I can do those two square roots separately. Square root of 100 is 10, square root of 9 is 3, and boom, we're done. In the one on the right, life is a little bit easier if I put this under one big square root, because then I can do some simplifying. 48 divided by 6 is going to end up just being an 8. X to the third divided by x is going to be x squared. So now this becomes all I need to simplify. 8, I can split into 4 is a perfect square times 2, and then x squared is itself a perfect square. So the square root of 4 I can pull out, the square root of x squared I can pull out, and I'll have 2 times x, and then I still have a square root of 2 left underneath. Okay, and then that would be my most simplified answer there. If you are adding and subtracting square roots, as long as the radical, or the stuff underneath the radical, is exactly the same, then it's really just like combining like terms. So if I have 7 times the square root of 11 plus 6 times the square root of 11, that's going to give me 13 of those square roots of 11 when I'm done. Okay, so down here on the left, 7 square root of 2 plus 5 square root of 2, that's 12 altogether, still multiplied by the square root of 2. Nothing fancy, nothing too tricky here. Even if the stuff underneath involves variables, as long as it matches, we can keep doing the same thing. So in this one, it's technically 1 of these minus 7 of those. So we actually will have a negative 6 out front, and then multiply by the square root of 5x. So if everything matches to begin with underneath, you just treat it like combining like terms. If they do not match, then we might need to do some simplifying first. The square root of 2 can't be broken down anymore, but the square root of 8 we can fix up a little bit. So I'm going to change that square root of 8 into the square root of 4 times 2, because now I'll have the square root of 2 plus square root of 4 times 2 when I split those apart. And now I have the square root of 2 plus 2 square root of 2. Sorry, that went off the end a little bit. So now I really have 1 times square root of 2 plus 2 times square root of 2. That's going to give me 3 times the square root of 2. So if they don't match to begin with, we just need to double check, is there any way I can simplify them to make them match? Okay, so in the one here on the left, this 12 is the one I can fix up a little bit. 12 can split into 4 times 3, so that now I would have that, and square root of 4 is a perfect square. So this original problem turns into 7 square root of 3 plus 2 square root of 3 after I take the square root of 4 that I split apart. Now I can combine them. 7 plus 2 gives me 9 times the square root of 3. And then the one on the right. If I have 4 times the square root of 50x minus the square root of 32x, those do not match, so I'm going to have to do some work. This one I can split into 25 times 2. 25 is the biggest perfect square that 50 splits into. And I've got that 4 out front still. Minus 32 can split into, well, let's see. 32 is divisible by 8. We could go 4 times 8, but we can do better. We can actually do 2 times 16. 16 is a bigger perfect square than 4 is. So we're going to do 16 times 2, and then we still have that x left behind. And then what happens, I have 4 times the square root of 25, that's my perfect square, underneath I'm still going to have left a 2x, then minus square root of 16 is a perfect square, so I'll pull that out, or pull that apart, but then I'm going to be left with 2x behind. So now I have 4 times, the square root of 25 is 5, times the square root of 2x, and then the square root of 16 is 4. I still have the 2x left underneath. These two just get multiplied. So 20 times the square root of 2x minus 4 times the square root of 2x, and we're almost done. Now I can finally, now these two match perfectly, I can finally do 20 minus 4 is 16 times the square root of 2x. And that would be my final answer there.